Hello everyone, in this video we'll talk about the activity series of metals and non-metals and how do we use the activity series chart in order to predict the products of a single replacement reaction. Let's start. Right, so here is our activity series chart. Right, so the activity series is a series of all the metals, and as we go down the series, the activity of metals or the reactivity of metals decreases. So towards the bottom we have least reactive metals, and towards the top we have the most reactive metals. Right, so we have kind of our reference point. So hydrogen is the reference point. So I'm going to highlight hydrogen on the activity series. And then the other reference point is sodium. So I am going to highlight sodium as well. Okay. So now let's see how we use the activity series of metals to predict the products of a single replacement reaction. Okay. So now for single replacement reactions, metals replace other metals if they are above the metal being replaced. For example, if we have aluminum as the element, the incoming metal, and we have an ionic compound lead 2 nitrate, so we need to see whether aluminum will kick out lead and make a new compound with nitrate or not. For that we need to look at the position of aluminum and lead and compare them. Right, so we have aluminum right here, and then lead is here. So lead is below aluminum. That means aluminum is more reactive than lead. If the metal is above the other metal, it means this one is more reactive. So this is more reactive than lead. So aluminum will kick out lead from its salt. Right? So we need to replace lead with aluminum. Whenever we have to make a new compound, always remember we have to do the crisscross between the ions again. So for writing the product, we need to know what kind of ion would aluminum make. So aluminum makes 3 plus, we know that, and then aluminum is going to kick out lead and it will make a new compound with nitrate. The formula of nitrate is NO3 1 minus. So do the crisscross, and the formula of the product would be aluminum NO3 3. So this is aluminum nitrate. Okay, this is how we write down the product. Now lead gets kicked out and lead come out as Pb. Always remember, whenever we are writing the products of a single replacement or a double replacement reaction, the products should not have any charge. They should be neutral. Right? So you can do that in your scratch work. Right? But when you're writing the products, they should not have any charges. Okay? They are neutral compounds. So lead will come out as lead atom, element lead. Right? Then once we have written down the products, then we need to balance this equation. Right? So I already kind of made a video on how to balance the equations. So you can check the coefficient of the balanced equation are 2, 3, 2, 3. Try to balance it on your own and see if you get that coefficient. Okay. Next, we are going to do another reaction, magnesium versus zinc chloride. Right? Now let's look at the activity series of metal and look at the position of magnesium and zinc. So magnesium is right here and zinc is below magnesium. So this means magnesium is more reactive than zinc when we are comparing that. So magnesium will kick out zinc from its salt. Okay, so magnesium will kick out zinc. Now this is going to kick out this and it will make a new compound with chlorine. So for that we need to know what kind of ion magnesium makes. Magnesium makes 2 plus because it's a group 2 alkali metal, and chlorine makes chloride ion. Then you do the crisscross and the formula of magnesium chloride is MgCl2, and zinc will come out as a neutral atom, zinc, right? Next you balance this equation. So 1 1 1, so this equation is already balanced, right? So all the coefficients are 1 1 1 1. Okay, next let's look at this reaction, copper with zinc chloride. Now let's look at the position of copper. So copper is right here and zinc is here. So zinc is above copper. Okay, this means zinc is more reactive than copper, right? So if copper is the element, since copper is less reactive, than zinc, nothing will happen. So there will be no reaction when you put copper metal in zinc chloride solution. So there would be no reaction. Okay, so this is how we interpret the activity series of metals when we have one metal as an element and one metal in the ionic compound, right? So we can see which metal will replace which. Okay, so these are the 3 examples that we did. Next we need to see what happens if we have an acid and a metal is put into the acid. Now always remember all the metals above hydrogen. So all these metals that are above the hydrogen, you can see all these metals are above the hydrogen. So these metals are more reactive than hydrogen. Hydrogen is not a metal, right? This is a non-metal. So all these metals that are above hydrogen can kick out hydrogen from the acids. So on the back side of your ion sheet, you have to memorize all the names of the acids and their formulas. Okay, so I have some examples here. Now magnesium is reacting with hydrochloric acid. So this is hydrochloric acid. Right? So all the metals above hydrogen can replace hydrogen in the acids. So magnesium reacting with HCl. Now look, magnesium is right here, it's above hydrogen. So magnesium is more reactive than hydrogen, so it will kick out hydrogen from the acid. Now how do we write down the product? So magnesium is going to replace hydrogen. One element replaces another, and magnesium will make a new compound with the anion Cl, right? So for that we need to know the ions. Magnesium makes 2 plus and Cl is 1 minus, and the formula of the compound would be MgCl2. Okay, and since hydrogen comes out, hydrogen will come out as H2. Always remember it's a diatomic. So you need to memorize the list of diatomics. Horses need oats for clear brown eyes. all those elements that are on the diatomic list, they will come out as a diatomic. So always remember, hydrogen is going to come out as H2, not H. Okay. Next thing, so we have predicted the products of this single replacement reaction, and next is we need to balance this equation. So you can put the coefficient, so there would be a 2 here, and then this is now balanced, right? So the coefficient of balanced equation would be 1, 2, 1, 1. Okay. Next, let's see this example. So we have sodium next to phosphoric acid. So this is phosphoric acid. You can memorize its name. Now let's check the position of sodium and hydrogen. So sodium is right here and hydrogen is below sodium. So that means sodium is more reactive than hydrogen, and it will kick out hydrogen from the acid, right? So now this sodium is going to kick out the hydrogen, okay, and it will make a new compound with phosphate. So this is the anion. So sodium makes Na1 plus and phosphate is PO4 3 negative. So do the crisscross and write down the formula. So that would be Na3 parenthesis PO4. And hydrogen will come out as H2 gas. Right? It's a diatomic. So hydrogen, when comes out from the acid, it's replaced by a metal from the acid. It will always come out as H2 gas. Next thing is we need to balance this equation. So I can put the coefficients. So we will have 6Na, 3H3PO4, 2Na, 3PO4, and then 3 here. Right? You can check, try to balance it on your own. So the coefficients are 6, 3, 2, 3. Okay. Next, let's try to balance another equation. Okay. So we have a metal, silver, and we have an acid which is called sulfuric acid. Right. Now let's see the position of silver and hydrogen on the activity series of metal. So hydrogen is right here and silver is below hydrogen. Now this means silver is less reactive. So this is less reactive than hydrogen. So silver is less reactive than hydrogen because it's below hydrogen, right? So silver will not be able to kick out hydrogen gas from sulfuric acid. So there will be no reaction. Okay. So always remember, the metals that are above hydrogen can replace hydrogen in the acids, right? So this is a second type of single replacement reaction. The first type is metal replacing other metal, okay, and then the second type is metal above hydrogen can replace hydrogen in the acids. The third type of single replacement reaction that we need to know is when metals can replace hydrogen in water. Remember we highlighted sodium. Sodium, including sodium, all the metals that are above sodium, right? So these metals can replace hydrogen from water as well. Okay. So sodium, calcium, strontium, barium, potassium and lithium, they can all kick out hydrogen from the water. And always remember, whenever water appears in single replacement or double replacement, always write water as HOH. Okay, so let's do some examples. So metals from sodium upwards can replace hydrogen in water as well. So lithium reacting with water. Now lithium is above sodium, right? So this is one of those few metals that will kick out the hydrogen gas from water. So lithium will kick out hydrogen and it will make a new compound with OH of the water. So lithium makes Li1 plus and OH is 1 minus. So the formula of lithium hydroxide would be LiOH, and hydrogen will be given out as H2 gas. Okay, and next we need to balance this equation. So I'm going to put a coefficient of 2, 2, and then 2 here and then 1 here, right? So the balanced equation would be 2, 2, 2, 1. Okay. Next, let's do K plus HOH is similar to what we saw in lithium. Since potassium is above sodium, that's potassium, it is going to kick out hydrogen from water, right? Or maybe we can do calcium this time. So let's do calcium. So calcium is more reactive, right? And then it will kick out hydrogen from the water and it will make a new compound with OH. Okay, so calcium makes 2 plus ion and OH is 1 minus. So the formula for calcium hydroxide would be CaOH2, and then hydrogen will come out as hydrogen gas. Next, you can balance this equation, right? So we have calcium, we have hydrogen, we have OH, and then on this side we have the same elements. Keep OH as a chunk. That can only happen when you write water as HOH always, right? So we have 1 here, 1 here, and 1 here. On this side, 1 calcium, 2 hydrogens, and 2 hydroxides, right? So let's fix the hydrogens on this side. I'm going to put a coefficient of 2 here. Okay, so now that I changed hydrogens, but I also changed the hydroxides. So this is 2 now. Okay, so now this is balanced equation. So the coefficients are 1, 2, 1, 1. Okay, so this is now balanced. Okay. Hope that video was helpful.